Hi everyone, my name is Mariam Khalid. I'm the Director of SOC Offensive Security at Barracuda XDR. And today we're going to be talking about how Databricks powers real-time threat detection for Barracuda XDR. So before we get into the nitty-gritty, I want to set the stage a little bit about why what we do is so important and talk a little bit about the global threats that we see on a day-to-day. All right, so let's talk a little bit about some of the metrics that we've seen. So in 2023, we actually saw a 95% increase in ransomware attack year over year. This is no longer an outlier. This is something that we are seeing increasing on a year-to-year basis. And we really need to shift to a more of a proactive approach rather than a reactive approach. Some of the other stats that we did see was 48% of organizations experienced phishing or a social engineering attack in the past year, with over 40,000 common vulnerabilities that were released on a year-to-year basis. Again, I'm not going to go through all the metrics, but these are essentially signals for us that we need to basically up-level our approach, right? Because the threat volume is increasing, the cost is increasing, and the complexity is increasing because of things like AI. So what is Barracuda XDR? So Barracuda XDR is an open, extended detection and response platform that combines sophisticated technology with cybersecurity analysts, cybersecurity engineers, backed up by a security operations center that is 24/7, 365. And when you look at this shield, you want to think of a house, right? So there's multiple ways a threat actor can break into your house. XDR is built to cover every single gap that you may have. So it could be either the back door, it could be the front door, it could be a window. XDR is built to make sure that threat actor does not get in. So we actually support over 50 integrations right now, from the most advanced technologies to SaaS solutions like Microsoft 365, Google Workspace. And some of the benefits of this, it's a fully managed SOC, so monitoring your network 24/7, 365, the ability to detect and respond rapidly to threats, so automated threat response. If we see a user being compromised in your environment, we'll actually go ahead and disable it. And most importantly is the Cyber 911, so the ability to call someone when you're having an incident or a breach, and really gives our customers that peace of mind that we have their back. So how does XDR work? And it's honestly very simple. So we collect your data via API or XDR agent, and we're only collecting data that we care about, data that is providing security value. Then we normalize that data, parse that data so that it can easily be processed by our SIEM for detection, our SOAR platform for automation, and our threat intelligence platforms. And then once we have your data, we really have you covered from end to end, because we're actually going to take that response action as well when we do see a compromise within your network. Lastly, but not least, we have an interactive way for our partners and our customers to see the alerts via our customer security dashboard, and it's completely self-service where they can actually integrate new data sources and set up automated threat response. So I want to talk a little bit about why we chose Databricks, and I think everyone within the business landscape for cybersecurity knows that legacy SIEMs are getting more and more expensive, with insane storage costs and insane processing costs with no real-time detection. Since Databricks is built on Apache Spark, it's automatically optimized for processing huge amounts of data with fast querying. And not to mention that it comes with a fraction of the cost. Also, legacy SIEMs, there's a lot of built-in machine learning capabilities. However, with Databricks, we are able to train and optimize all of our data to our needs. So I want to talk a little bit about our Barracuda's journey and Barracuda and Databricks partnership. So this actually started back in May 2020, so a little over 5-6 years ago. We integrated our enterprise platform that gave us a unified foundation for managing product, enterprise, customer data while enabling our teams for advanced reporting, business analytics, which was very helpful. In 2021 and 2022, we used Databricks for our advanced technology group, which is a backbone of our Gen AI initiatives that we have across Databricks. And Databricks essentially helped us build advanced tracing and troubleshooting mechanisms. In 2023, we used Barracuda. We integrated Barracuda email protection into Databricks for the machine learning classifiers. And then fast forward to 2025, we are now integrating continuous integrations with XDR for automated threat response detection engineering, giving us the ability to scale detections across thousands of our customers. So this is, sorry, one second, our migration journey. So this timeline really highlights the transformational journey from legacy SIEM to a modern, scalable detection engine and data lakehouse we've built. And we took a very phased and disciplined approach where we tested early, we validated at scale, and we honestly improved at each and every milestone that we have. So back in August 2023, we kicked off things with a small but very, very powerful POC where our goal was to prove that Databricks could ingest, parse, and trigger alerts for our customers. And this stage really showed us what the different possibilities are with Databricks. And then in September 2023, this was where we scoped out some of our success criteria. We rolled up our sleeves and we were like, this is what success will look like for us. We looked at the different requirements for SLAs, for data transformation, for data modeling, storage pipelines, orchestration, and monitoring. And then in January 2024, this is where we started building our Databricks architecture with using autoloader for ingestion. We used Browns to Silver for data transformation, and we also started using DBT warehousing for detection engineering. August 2024 is when we started our first integration, which was Microsoft 365. We integrated about 40 plus detections across 5 different workspaces across the globe. And we also integrated with some of our downstream notification systems. And then fast forwarding to May 2025, most recently we just deployed FortiGate using streaming workflows and our updated detection engine that Alex will talk about. We also integrated 20 plus detections, proving that the system is not just good for Windows or Office 365, we're also able to integrate network data as well. So from POC to integrating multiple different sources, it wasn't just migrating the data, it was really about evolving our entire detection strategy. So we were shifting our mindset to more of a detection as code rather than some of what the legacy SIEMs have to offer in terms of detections. I'm going to hand it off to Alex to go through our SIEM that we've built inside Databricks.
Thank you, Miriam. My good level? Perfect. All right, well, good afternoon, everyone. I know this is an awkward time. It's either before lunch or after lunch, so I either got food comas or stomachs growling. But thank you for coming and listening today. We will be talking about how we built a SIEM inside of Databricks and going through some of those technical diagrams and system architecture. But fundamentally, what we're talking about is how we take logs and telemetry and transform them into alerts, which indicate security incidents. So I just want everyone to remember, we talk about SIEM, that is what we're talking about, transitioning from logs to alerts. It's not lost on me that they let a security guy talk at a data engineering conference. So I wanted to kind of convince you that what security engineering is just another flavor of data engineering. And in order to build a SIEM inside of Databricks, you must follow best practices for data engineering. Databricks is a great canvas for us to paint that solution. And hopefully by the end, you'll see why we chose Databricks and how it works. What is detection engineering? Fundamentally, we talk about the process of how we identify security incidents, is what we actually mean by detection engineering. And we have to do a lot of research in the beginning to understand what threats we're hoping to detect, what's required to do that type of detection. And that is what we're talking about when I say detection engineering. At Barracuda, my team is the detection engineering team. We have people that focus a good chunk of all of their sprint cycles just on researching threats and understanding how we can deliver these detections to our customers who send us the logs. How has it evolved over time? It's been around for over 30 years as detection engineering. It started from a very static binary signature-based model to more heuristic-based baselining, and of course, leveraging software engineering best practices with detection as code, which we'll highlight in a second. But really what we're doing is taking all of our detections and figuring out how we're going to express them. And that's really what we talk about with detection as code, is how we express detections, how do we store them, and how do we deploy them to be executed and generate alerts. Some of the trends that we're seeing in the security space today with threat detection is around understanding the data that you want to use for creating those alerts, but how we enrich that data is quite important. Just a basic example is geolocation. Most logs that we collect are just IP addresses. So adding in something like geolocation paints a better story, tends to result in better outcomes for threat detection. Another thing is real-time detection, and real-time is in quotes because nothing is really real-time. There's always some latency. But real-time shrinks the dwell time that an attacker will be inside of a customer environment, and decreased dwell time means less of an impact from a security point of view. So think about detecting ransomware threats. It's kind of important to know about a ransomware threat before encryption occurs. So real-time detection allows us to do that. Finally, we talk about automation. That's going to be something that comes up in a lot of these presentations, is how we can take those alerts, how we can take those signals, create really robust automation pipelines to be able to respond in real time to security threats. And finally, taking some of the more binary detections and converting them into ML classifiers, how we compute baselines, how we can reduce our false positives, and the volume of the alerts that we send using statistical models. And just to showcase like a finished product that our XDR team recently delivered to customers, we have an ML classifier that detects account takeovers. These alerts fire in Databricks, and we have an automation pipeline that will reach into that customer environment and suspend the users that we suspect have been involved in a takeover attempt. All right, so we are going to start our journey in how we build a SIEM, but first we have to talk about the parts of a SIEM. And I realized I didn't define what SIEM stands for. SIEM is Security Incident and Event Management, but all this is a data lake full of our events, and we're trying to figure out which events constitute a security threat. So these are the 8 core pieces that I can think of that every enterprise SIEM that you purchase, you would expect supports these features. And I divided them into 2 sections. So the ones that Databricks already supports, really out of the box, there's a lot of options. Of course, when we talk about ingestion, it's a lot more simplified on this slide. But these are some of the major components that already exist inside of Databricks. And then we talk about the custom features, which is really what we're going to focus on today, is the custom features. And these are our detection rules, our deployment pipeline, the engine itself, what executes the detection rules, and finally, our alerting. All right, so what is a detection rule? Detection rules is what most teams refer to a detection analytic, and these are templates for how a detection should work. And I literally mean templates. These are stored as templates prior to their being deployed in Databricks. We talk about detection as code. The code piece in detection as code refers to the markdown language that we're using to store these detection rules, which are the templates. We support 5 different types in Databricks as of today, and we're not going to go through each one of these, but the types give us the macros for how we're going to detect a threat. So let me give you an example. The last one on the list is threat intelligence, threat intel. That rule type takes 2 tables, a threat intel table and a customer log table, and we match on common fields like an IP address, hash, some common indicator value. And that is specific to that rule type. So you can think we support a lot of different methodologies for detection, but the templatized macro format allows our engineers to be a little bit creative in terms of which one they select, but also it's very apparent what I need to fill out to be successful to build my detection. And here is a preview into what that looks like. So my team uses GitHub, and we use a GitOps approach where we have our various branches, and the branches corresponds to our workspaces, our Databricks workspaces. So if a rule is in development, it's targeting our Databricks development environments, our workspaces. And if you are an engineer on my team, the only thing you need to know is how to build a template. We've abstracted away all the other nuts and bolts. You just have to build the template in order to create the rule. And this is the beauty of detection as code. That was a big goal for us, is how do we abstract away a lot of the technical data engineering for a security team that maybe doesn't have those data engineering skills. And this allows us to do that. So this is TOML, for those that can't recognize that. This is TOML. This is a version, it's a different flavor of YAML for storing mostly configuration templates. And we've actually built a validator on top of these templates that will build dynamic SQL queries and lint them. But more importantly, check for any violations, like, hey, I'm missing a key value pair, or I've specified a column in my SQL query that does not exist in my schema. So we've actually built a custom validator to make sure that any template that we introduce into our deployment pipeline is free from errors, relatively. Can't detect everything, but good enough to be able to deploy it to Databricks. Each one of our detection rules is stored as a TOML file in a GitHub directory here. As you can see, we store them by data source, then rule type. All right. So we have a template. We built the template. It sits in a GitHub repo, but now what? What do we do? So this is our deployment methodology. It's very simple. It doesn't have to be complex. We are, again, using Databricks workflows, which we're going to talk. Our detection engine is also Databricks workflows. But this is, I think, kind of a creative way to deploy to Databricks. We have a GitHub action that we ultimately run on the GitHub side, and it produces what we call workflow inputs. I've highlighted some of those. We call them, they're just notebook parameters. So what are the changes that you're doing? The action identifies those changes and supplies a repo deployment workflow with those inputs. And the underlying notebook that's attached to our repo deployment will accept the inputs passed through GitHub and change what we call a detection metadata delta table. And that detection metadata table stores the parsed versions of all of our TOML files that it showed in GitHub. If you are an engineer, again, all you're doing is running the action. You're not seeing the workflow running in the background. You are getting notified in Slack when your deployment's successful, trying to abstract away some of the in-the-weeds Databricks workspace interactions and just making this a really smooth integrated experience. There is a lot of other things that we can do with repo deployment. So we do code, if we change the underlying Spark code base, we would do another type of deployment. It's all supported through this same methodology. All right, so this is perhaps the slide that interests most of the people in this room. This is the detection engine, and this is what enables us to create security alerts from the logs that we get from our customers. So I'm going to step through this as high level as possible, and then at the end, of course, if there's any questions, we're happy to revisit this slide. We have inputs, so I talked about our detection metadata table. It stores how our rules operate. And then we have all the associated logs that those detections operate on top of. We have intermediary tables, so think about like machine learning scoring, for example. Those are going to produce sources that we can operate rules on top of as well. We're going to read all that data using a read stream into our continuous Databricks workflow. And the way we've done this is we have a streaming notebook that exists per data source. So I've given you 3 examples here. This is Microsoft Office. Laser's not going to work for me. Microsoft Office 365 streaming notebook, Microsoft Windows, which is server syslog, and Fortinet FortiGate, which is a firewall. So we have a notebook for each data source, and they are executing our rules in a for each batch. So that's a Spark write stream method, by the way. And that allows us to iterate through all of our rules that we're reading from our detection metadata table and execute them to create what we call the raw signal. We're not done yet. Raw signals is just one step of our overall architecture here. We then do a union stream where we take all of those raw signal tables, which all have the same schema, and we union them together and process them. And the alert processing is required to fill 3 use cases here. So the first one's suppression, the second one is exceptions, and the final is notification. And we're going to cover that in detail on the next slide. Fundamentally, we have to have a way to get these out of Databricks to our customers, because our customers don't live in Databricks. So we send these off to either our SOAR platform for automation, or we send them directly to our case management tool that sends them to customers. And then finally, the output of those alerts is written to one table. And in that table includes all of the processing and logging that's required to make this work. We don't want a lot of separate tables to kind of see what the story was on the customer alerting. So we actually keep and capture everything in that one central alert table. All of our, our code's pretty resilient to errors, but if we do encounter any specific rule level errors, we actually are able to log those to tables without killing our Spark workflow. We also do streaming as well. As you know, we're reading from multiple tables that some are bigger than others, some have more columns than others. So we want to capture some of those Spark metrics as well. And we use our Spark query listener to be able to do that. All of this runs on job compute using a Photon engine. And we are running this per workspace. So each development workspace, staging, and production workspace is running some version of this workflow with the associated rules. All right. So I mentioned some alert handling challenges, and if you've never had to onboard a SIEM before, you may not know that these are actually challenges. But we can't just send every alert that we trigger to a customer. If we did that, our customers would be very upset with us because there is inevitably things that are going to happen in terms of patterns that result in alert flooding. Let's say someone is doing a software deployment in their environment, and it's triggering 1,000 alerts for some detection that we've created. We don't want to send 1,000 alerts to the customer for the same activity. So we have this idea of suppression, where we can group alerts based on similar columns and suppress them for some time period, let's say an hour, for example. So our processing pipeline allows us to do that. The second one is similar, exceptions. Exceptions are more long-term suppressions, so that's the big difference. Exception says the customer is acknowledging that the detection rules should not be firing under these pretenses. We can then create an exception so that that rule never fires for that customer. These are stored in another metadata table that's read in by that Spark job. And we actually have a GenAI-powered web application that assists our SOC team in being able to create those exceptions in Databricks without having to actually do a table insert. Remember, my goal was to abstract away a lot of the things in Databricks for those that aren't super familiar with data engineering. And the final thing I wanted to mention on this slide is we aren't using a lot of dependencies. Okay, we want it to be as simple as possible. So everything in Databricks 16x runtime, the Python standard library. There is one exception, and that is PySpark IP. PySpark IP is not included in Databricks runtime, but it is a library that we needed to be able to build the IP address UDF. This allows us to treat IP addresses like IP addresses and not strings. IP addresses have subnets. Strings do not have subnets. So we need to be able to process this type of IP data, so we had to use PySpark IP. The rest all comes for free in Databricks, which was really nice. It means simpler development experience overall. Alert output. So this is just a sampling of some important columns so you get the idea of how we're storing our alerts. We have about 50 columns, so I could not have fit them all on this slide. But we include metadata about the alert, such as like the MITRE information, the type of rule that we're dealing with, the name of the rule. And then we add in a lot of other extras, like dynamic alert summaries, SLA tracking, like how long it took us to generate an alert in minutes. We have rule-specific fields. So I talked about threshold rules and how we do aggregations. Storing the aggregation result for a detection, it might be very important. So we've actually done that down here. You can see we store the aggregation result. We also include our processing outputs. So I mentioned we have the idea of an exception, potentially removing an alert. We have a suppression that also could remove an alert. If we don't store these, we have no idea what actually prevented that alert from firing. Very important for us to have that, as well as the notification status. So the notification status is where we sent the alert after it triggered. If we try to send it somewhere and we get a 400 error message, we probably should know about it. So we're able to do that inside the Spark workflow as well. What does a customer see? A customer just sees this. So they get a notification that a security incident occurred inside their network or their environment or their cloud system, and it will summarize the event. This is actually using our in-house Barracuda AI Insights. And then they can click on the alert to view it inside the dashboard. All of the data that we have in there is obviously powered by Databricks. Finally, success doesn't happen in a vacuum, and I think really one of the things I wanted to mention is that we didn't get everything right on the first go. That's part of our engineering process is trial and error, what works, what doesn't work. And I think every team is different in how they do this trial and error process. We did have DBT and warehousing as our first detection engine 1.0, so to speak. This did not provide us the real-time detection that we were looking at, as you have to schedule models with DBT. So we were looking for a more real-time approach. So we switched over to DLT after that, as Miriam mentioned in our earlier slides. DLT was great. There was no problems with DLT. Fundamentally, the way our streaming workflow works is very similar to how it worked in DLT. But we wanted to have our team do a deep dive on the streaming side, really become experts. And DLT, as maybe a lot of you know, is a declarative framework. It abstracts away a lot of the streaming knowledge, which was a shortcut for our team, but ultimately didn't allow us to add the customization that we needed. So we use the streaming workflow today. It is a modular code design where we import different classes. All of our detection rules are stored in a class that we import. We're able to make changes without having to restart the streaming jobs, which is a huge benefit. And overall, we're very happy with the streaming workflow, and we think it's going to set us up for success later down the road. And I will hand it back over to Miriam to talk about some challenges.
Thanks, Alex. Thanks for the deep dive. So we've had a few challenges along the way, and we want to be fully transparent and share some of the bumps we hit along the way and the road bumps. Like any major transformation, the migration came with its learning opportunities. But what stood out to me the most was how resilient our Barracuda team was, and also our Databricks support team. They stayed with our side across the whole migration journey. But one of the biggest shifts that we had was training multiple teams. within XDR on the Databricks Lakehouse architecture, with if that included managing ELT pipelines to building dashboard, Databricks SQL queries, building visualizations. As Alex mentioned, we're now evolving towards a detection as code model where data engineer skills and programming skills are central to maintain and improve our detections. It's essentially, as I mentioned before, it's a shift in mindset. So one of the other things that we did struggle with was optimization and best practices. It wasn't something that was plug and play. We experimented a lot with warehouse configurations, number of node sizes, number of workers, to get that best combination with cost and performance. But I did want to give a quick shout out to our Databricks team for the support and the best practice in terms of the best practices that they gave us throughout the whole migration. So some of the benefits that we encountered as we moved to Databricks is that we were actually saving a overall 75% cost daily in both processing and storage costs compared to traditional SIEMs. We're also alerting our customers faster. So customers actually receive our alerts within 5 minutes of logged alert detection, which is a significant improvement in terms of retaining our customers and in terms of the response time. And one of the other things was ease of use. So our detection engineers can actually now focus on studying new and emerging cyber threats and building new detections rather than managing and scaling new infrastructure. And then also scaling onboarding. So we're actually at a place right now where we're able to integrate and migrate over multiple data sources at a time compared to when we first started. So when we first started, we were migrating just one data source, and right now we're actually doing 3. So the platform that we've built is very scalable. I do want to just talk a little bit about some of the future plans that we have and looking ahead. So right now we still have some data sources on a legacy SIEM, and we want to migrate everything over to Databricks, which is about 50 plus data sources. We also want to do some cross-platform collaboration across Barracuda. So as Barracuda adopts Databricks throughout their different products, we want to share intel, we want to share threat intelligence, IOCs. We want to build new machine learning and AI use cases for detections. And then last but most importantly, we want to continue collaborating with security professionals that are in the Databricks ecosystem, because we're all in a shared mission, right, which is protecting against cyber threats and getting the bad guys out. Right, that's it.